Okay, start now. Start.
Hello everyone. Today we have presentation about blockchain. So Ali Abbas will present about blockchain. Yeah, thank you. Start now.
Okay. So, good evening everyone. My name is Ali and today I will talk about blockchain. So, this is the agenda for today's presentation and let's begin. Okay, so blockchain. Blockchain is actually a distributed ledger, more like a database that helps us store data in a decentralized manner. The potential applications for blockchains include funds transfer, settling trades, voting, and many others, and also the banking transactions as well. Business networks benefit from connectivity, connected customers, suppliers, banks, and partners. Wealth in blockchain is generated by the flow of goods and services across business network. Anything that is capable of being owned or controlled is actually an asset in the terms of blockchain. So, history of blockchain. So, in 1991, Stuart Haber and Scott Stornetta introduced the concept of cryptographically secured chains of block. Then in 1992, Haber, Stornetta, and Dave Baer incorporated the Merkle trees that became the building blocks for blockchain. This improved the design and efficiency and allowed several documents to be collected into one block. Then in 2004, computer scientist Hal Finney introduced the concept of reusable proof of work, which is actually a consensus mechanism in blockchain. Then in 2008, the very famous Bitcoin's white paper, peer-to-peer electronic cash system, was introduced by Satoshi Nakamoto. This is still a controversial figure because no one actually knows about Satoshi Nakamoto. The Bitcoin in 2009, the Bitcoin network goes live with the Genesis block, marking the first practical implementation of blockchain technology. Then we come to the working of blockchain. So Merkle trees are known to be the building blocks of blockchain. So in Merkle trees, also known as the binary hash trees, they are prevalent sort of data structure in a computer science. In Bitcoin and other cryptocurrencies, they are used to encrypt blockchain data more efficiently and securely. It's a mathematical data structure made up of hashes of previous data blocks that summarize all the transactions in a block. It also enables quick and secure content verification across big data sets and verifies the consistency of data. Working of Merkle trees. So let's suppose we have 4 transactions all executed on the same block of blockchain. Each transaction is then hashed. Hashed basically means that you assign each serial number or ID to a transaction. So we have 4 hashes, A, B, C, and D, and then we put them together like A, B, and C, D. Then the final hash that we get that is gotten by combining A, B, C, D is actually the Merkle root of our tree. That this constitutes into the blockchain then. So this is an example of a block. We have data stored on it, hash, and the hash of previous block. Then and this is an example of data. Then we have a hash. Hash is just like I said before, it is an ID or a serial number. We generate it using the SHA-256 in the infamous algorithm. Then this is how the blockchain connects together. We have multiple blocks together, and when we combine them, it creates a chain. Hence the blockchain. The Genesis block is the first block that stores the data, so it does not store any previous hashes. And the blocks following it then store the hashes to the previous block. So let's say we have been malwared, or an intruder has attacked the blockchain. So this is how the blockchain secures the data, that if you can change the configuration of a single block, but you cannot change the configurations of the previous blocks. Since each block also stores the hash of previous blocks, so it becomes difficult for the hackers to change each and every block's hash. Then we have consensus mechanisms that also aid into the encryption technology of blockchain. So modern computers can compute hundreds of thousands of hashes per second, hence they cannot tamper with a block and then compute and replace all the other blocks. So using hash only is not enough. So to mitigate this, blockchain has something called proof of work. It's a mechanism that slows down the creation of new block. Consensus is basically an agreement between the nodes in the blockchain network, nodes, or you can say users of a blockchain, which operates without trust between parties. Consensus are not owned or controlled by a single authority, rather it's the nodes across the world. Types of consensus mechanisms. So we have 4 basic types of consensus mechanisms. Number 1 is proof of work, the one I was previously talking about. Then we have proof of stake, delegated proof of stake, and Byzantine fault tolerance. Then we have smart contracts. Smart contracts work by following simple if this then that statements that are written into a code into a blockchain. A network of computer executes the actions when predetermined conditions are met and verified. These actions might include releasing funds to the appropriate parties, registering a vehicle, sending notifications, or issuing a ticket. Blockchain is then updated when the transaction is completed. So here we have a small example of a smart contract. We write a set of functions that help to decide and create a transaction with the owners and the next or the oncoming owner of a contract. Then we execute the smart contract, and then it automatically transfer funds and transfer ownership of different assets into the blockchain. Then we have decentralized finance. It's still in fancy, and it's still in its birth stages, but nonetheless it's a very helpful technology. DeFi eliminates third-party involvement in financial transactions using cryptocurrencies, blockchain, and software that allows people to transact financially with each other. DeFi is still in its infancy and subject to hack and thefts because of sloppy programming and a lack of security testing before applications are launched. Goals of decentralized finance are peer-to-peer financial transactions, and where two parties actually exchange cryptocurrencies for or goods or services without a third party involved. Uses of DeFi finances are accessibility, low fees and high interest rates, security and transparency, and autonomy. And we have NFTs. NFTs, non-fungible tokens, are unique cryptographic tokens that exist on a blockchain and cannot be replicated. NFTs can represent digital or real-world items like artwork or real estate. Tokenizing these real-world tangible assets makes buying, selling, and trading them more efficient while reducing the probability of fraud. NFTs can represent individuals' identities, property rights, and more. Collectors and investors initially sought NFTs after the public became more aware of them, but their probability has since then declined. Much of the earlier markets for NFTs was centered around digital art and collectibles, but it has evolved into a much more. For instance, the popular NFT marketplace OpenSea has several NFT categories like photography, sports, trading cards, virtual worlds, arts, collectibles, and music. Then we have different kinds of platforms. So we have 4 different kinds of blockchains. Number 1 is the public blockchain, private blockchain, hybrid, and consortium. Now we'll look at them one by one. Public blockchain. These blockchains are completely open to following the idea of decentralization. Anyone having internet and a computer with the good hardware can participate in a public blockchain. All the computers in the network hold a copy of other nodes or the data that is actually in the blockchain. Examples of public blockchain are Bitcoin and Ethereum. Advantages: it's trustable. There are algorithms to detect no fraud. Participants need not to worry about the other nodes in the network. Also, it's secure. This blockchain is large in size as it is open to the public. In a large size, there is greater distribution of records. Disadvantages of public blockchain is that the rate of processing is very slow due to its large size. Verification of each node takes a lot of time. Energy consumption. Proof of work is high energy consuming. It requires good computer hardware to participate in the network. This is actually considered the true blockchain network. All other parts are somehow the hybrids of these models. They are basically public blockchain is modified, and then a new blockchain is formed. So this is basically the building block of blockchain. Public. Private blockchain. These blockchains are not as decentralized as the public blockchain. Only selected nodes can participate in the process, making it more secure than the others. They are open to some authorized users. These blockchains are operated in a closed network. Examples are Hyperledger Fabric, Corda. Advantages: speed. The rate of transaction is high due to its small size. Verification of each node is less time consuming. Scalability. We can modify the scalability. The size of the network can be decided manually. Disadvantages: security. The number of nodes in this type is limited, so chances of manipulation are there. These blockchains are more vulnerable. They also are somehow centralized, so they do not serve the true purpose of blockchain. Trust building is one of the main disadvantages due to its central nature. Organizations can use this for malpractices. Then we have hybrid blockchains. It is mixed content of the private and public blockchain, where some part is controlled by some organization and other are made visible to the public in the form of public blockchain. Permission-based and permissionless systems are used in this blockchain. User access information via smart contracts. Even if a primary entity owns a hybrid blockchain, it cannot alter the transaction. Examples are Ripple network, XRP token. Advantages: ecosystem. Most advantageous thing about this blockchain is its hybrid nature. It cannot be hacked, as 51% of users don't have access to the network. Cost: transactions are cheap, as only a few nodes verify the transaction. All nodes don't carry the verification, hence less computational cost. Disadvantages: efficiency. Not everyone is in the position to implement a hybrid blockchain. The organization also faces some difficulty in terms of efficiency in maintenance. Transparency: there is a possibility that someone can hide information from the user. If someone wants to get access through a hybrid blockchain, it depends on the organization whether they will give it or not. And at last we have the consortium blockchain. It is a creative approach that solves the need of an organization. This blockchain validates the transaction and also initiates or receives transactions. Also known as federated blockchain, some part is public and some is private. In this type, more than one organization manages the blockchain. Examples are Tendermint and multi-chain. Advantages include speed. A limited number of users make verification fast. The high speed makes this more usable for organizations. Authority: multiple organizations can take part and make it decentralized at every level. Decentralized authority makes it more secure. Then disadvantages: approval. All the members approve the protocol, making it less flexible. Since one or more organizations are involved, there can be differences in the vision of interest. And that was it from the presentation part, and now I will show you a practical example of blockchain. So here we have a network of Hyperledger Fabric, and I will show you how to store data in it and also how to query data in this blockchain. So I hope you guys are familiar with APIs. Right. API is basically a communication interface that helps us communicate with two different systems, or you could say projects. So today I will use this software. It is called Postman, that helps us to test different kinds of APIs. So I will basically create some data, and then I will send it to the blockchain, and once blockchain verifies this data, it will send us the response that the data has been successfully queried into the blockchain. So here I've already written an array, or you could say a list. I will just change some parameters of it, like I will change its ID and some more values. So it's basically a test data that I have created for this example. And let's say 85. Now when we send this data, we can see that it has been successfully queried onto the ledger. If we look at the blockchain part, it will tell us that this data has been created onto the, or you could say stored onto the blockchain. And now we will, okay, so now I'll show you how to query this data onto the, so get document by ID. Okay, so we created this with the third ID. We'll query it with this ID number. Now when we query this data with this API, this is basically the API part. So API has basically 4 types when you query data. Number 1 is GET request. GET request basically is used to retrieve data. Then we have POST request, the data that is sent previously in this API. As you can see, it says POST. POST API is basically used to store data into a database, or maybe send data to another, like front end or back end communication as well. So we have basically 4 types of API requests: GET, POST, PUT and DELETE. PUT is used to update data that is previously already stored into the blockchain. And then we have DELETE, that basically serves the purpose as the name suggests. So now we will query this data with this 3 as a parameter. So when we send the data, we'll see that it shows us the result that this data is already present there. How I will now I will confirm this by logging into the database, and as you can see in the transaction, here is the data that we stored, and it has been successfully stored onto the blockchain, and we have already queried it as well. So this was a simple, although I can explain this blockchain to you, but it's a little more complex for your I could say for the scope of this presentation. so it's highly likely that you won't understand. So, but there are simple principles. The main, basically, this is Hyperledger Fabric, which is private in nature. We use this kind of blockchains for medical data or data that is not supposed to be made public for the users or for the normal everyday public or something like that. So it's more secure data, and that's why we use this kind of blockchain for. So yes, and that was it. If you have any questions, then sure, you can ask. So, any questions? Yeah, sure. Go on. Actually, it's working on the web. So all the attacks like SQL injections or any JSON attacks or Trojan viruses and all that stuff can happen. But the true spirit of blockchain is actually it's decentralized. Even if this system gets compromised, it doesn't mean that the data will be tampered, because it's already stored in a decentralized manner. So whoever has the copy of this blockchain, it's installed on the system. A hacker can change data in my system, but it cannot change on that system. And one thing I will also show you is that when I created the network, it created a hash with it. This, as you can see, is basically a algorithm you might have studied about it. It's called SHA-256. It's a hashing algorithm. So what it does is that it takes each single character of your data. Maybe if it's part of JSON data or a single string, so it will take each character of that string and convert it into 16 bits. So you get data like different random numbers and alphabets and a combination of that. So hence it creates the hash, and that's how data is protected. So this hash is created against this data. So anyone can, with the help of this hash, get access to the data. So it cannot be tampered. Yes. Anyone else?
How to work on tokenizations? How can relate with tokenization of the blockchain?
Tokenization as in this one, or?
Yes. Can you relate to this code? How to work on this?
Yeah. Well, to install Hyperledger Fabric, you'll have to look for the documentation, as it's a very lengthy process. But as far as the tokenization is concerned, yes. So tokenization is basically made. We have different functions to create hashes or tokens for this. For example, when I was creating this API, I need, like, for example, let's do it in front of you now. So I will create a user with the name use, or I could say user 2. Now what happens is that when I send this API, it will create a user and give us a token. Now what is this token? If you have ever worked with authentication or authorization, you would hear about a term called JWT token. So this token serves a purpose that whenever a user is created, a token is created against it. We use this JWT token to then create a user instance, and then we can use this to create data, or like to store data against this token number. It's kind of an ID, you could say, and its term expires after some time. So if I don't use this token within 10 to 12 hours, it will expire. Then I will have to create a new user. So I cannot keep it like permanently. JWT tokenization is basically a method that we use in web development to create different kinds of users. Otherwise, anyone can replicate a user and steal our data. So this is a kind of a verification process for us to create users. Yes. This is a web development kind of term, so I don't expect you to understand this, but still, hope I made my point across. No, it's not supposed to be stored. No, this token has nothing related to blockchain. It's only for the user verification and authentication. Whenever you create a user, you get an email, or you get some kind of a code, like a 6-digit code or a 4-digit PIN or something like that. This is serving the same purpose, but instead of a code or a PIN, we have a token. It's called JWT token.
So what is the fundamental of the blockchain transaction, and how different people can access?
Yeah. So to transact with you have to basically use APIs to communicate with the blockchain. You cannot do it like, like in web development sense, we use functions to query data or do something like, but in blockchain you cannot do that. You will have to create APIs. These are actually APIs. I am even creating users based on an API, because I cannot do with simple functions like register a user or add a document or then even get document. I'll have to create APIs for that. I cannot do this directly from the blockchain.
So how is work on decentralized?
Decentralized, I will show you. Okay. So what happens is that if I access the data for third organization or another organization, it basically does not allow us to get files from different so this is basically a channel where different organizations are registered, and if I am a member of one organization, I cannot access any other user's data or any other organization's data. Only the admin, since I am logged in as an admin here, only I can access the different organizations data. But for the other people who are users, like I just created one user in front of you, they cannot access other data.
Admin can access the whole data?
Yes, admin can access the whole data.
So what is the security?
Why is this? Security?
Admin can access all the data.
Yeah.
But where is the security?
The security is in this sense that the users cannot access each other's data. Admin can access this data, but that is actually the functionality of Hyperledger Fabric, that there has to be a mediator or an admin to control the database or everything. If you want only users without any interaction or involvement of other admins, you would go for open or public blockchain. That when I was presenting, I said that the true spirit of blockchain lies in public blockchain. All the other parts are actually serving some of the purpose of blockchain, but not the true sense of blockchain. So even in private or consortium blockchains, there has to be an admin that controls.
The admin can show, we can see all transactions.
Yeah, only admin can see the transactions happening. Like I can see who transacted and what kind of data I transacted. Like I can see this one and the previous ones as well, as you can see. So, but the users cannot access this database. They can only store and retrieve database based on their IDs and parameters. That's it.
I think in database system, one user cannot access the another user.
Yeah, no, cannot.
So what's the difference between blockchain and the basic database?
Blockchain helps you store data on multiple ledgers basically. So this same database or this same decentralized database can be shared along other users as well. So data actually cannot be changed. That's the basic purpose of it. It cannot be manipulated. Even if it got manipulated or attacked on your system, it won't be on Arif's or my system. My system will have the data intact.
Only admin can read only, don't write.
Yeah, no, read only. Yes, no write. Read or manage the data, that's all. Not more than that. Yeah. Anyone else?
Anyone else? We need questions for blockchain actually. We want to clear concept about blockchain.
Yeah.
And we are looking for 1 or 2 or 3 students for who wants to work on blockchain for next 1 or 2 years. So if you must if anyone interested, just help me personally and now ask everyone one question to make your concept clear.
Yeah, sure. Go on.
Just basic questions. Because it's just 25 minutes, so we can make it 40 minutes.
I mean, to make it basic, I had to cut it short. So.
Basic.
No. Nothing?
Can you explain the main applications of the blockchain? Different.
Yeah, well, blockchain, its uses are mostly in financial ways, like supply chain management or healthcare data or other such systems that, where the data is actually very insensitive kinds. It's also being used in like atomic stations as well. Blockchain, yeah. the PT organization in Pakistan that is currently handling the communication. Recently, you heard about the firewall in Pakistan. That is actually working on this principle of blockchain. That's how they trace you down and disable your phones, so you cannot use SIMs that you have illegally bought. So yeah,
We can use for sensitive data.
yeah, basically sensitive data.
Can you explain about the hyperledger?
Hyperledger Fabric. Hyperledger Fabric is actually a private blockchain, example of private blockchain that that has multiple nodes in it. So nodes, a node can have three purposes. Number one, it can commit a transaction, it can store a transaction, and it can order a transaction. So we have multiple types of peers. This system that I am working on currently has 3 peers. So 3 peers means that it has 3 kinds of nodes. 2 peers are for the emitters that are basically emit the transaction, that store the transactions, and 1 peer is called the orderer that orders the transaction to be stored onto the blockchain. I am queuing data in a form of a single entity that is array or a list. If I increase the length of the data, it will take more time to store the data because it will have to get verified actually. So it is also, like you could say, it takes its time, and it's working on the consensus mechanism of proof of work. So what proof of work does is that you have heard about the terminology of miners like in blockchain that do Bitcoin mining. So what happens is that miners have different high intensive systems that help with mining different blockchain data. They work on the principle of proof of work. So what happens is that when a transaction happens on the blockchain, to register a blockchain, they give those systems a complex puzzle where they assign them different entities, and they have to identify their hash, the hash that I created here. They have to identify that hash, and it takes a lot of, they have to go through the whole chain and each and every block and data segment to find that hash. And whoever first finds the data hash gets rewarded by a small amount of Bitcoin. That's how the concept of mining works. It is based on the consensus mechanism of proof of work. This is how it works. So when it finds the hash, it gets rewarded in a small amount of Bitcoin, like 0.001 something percent. And that's how the basic principle, that's how the blockchain system actually works. So in this case, it happens, same happens as well. So yeah.
My question is that how Hyperledger Fabric is different from the other blockchain like Bitcoin and Ethereum.
So Bitcoin and Ethereum are public networks. Anyone can join the network, do transactions in that network and get stored on the network, but every other user can see their data. Like for example, I can show you the amount of Ethereum the owner of Ethereum holds right now because it's on a public blockchain. So like everyone can see it. But in private blockchain, what happens is that your data is actually only available to you or the admin. No one else can have access to it or see it. That's the basic function of a blockchain, Hyperledger. Yeah.
What is the difference between proof of work and proof of stake?
In proof of work we have mining concepts, and proof of stake we have a different kind of concept where the users have to they have different data like verification mechanisms, and it is not actually that detailed for that matter. Yes, proof of work is basically puzzle solving, and proof of concept or proof of stake is actually just like verification of consensus or hashes. It's a computational process. So yes.
I have one more question.
Yeah, sure.
What is the lead of blockchain in supply chain?
Supply chain the need of a blockchain is supply chain management. Well, with supply chain you also need real-time data communication and accessibility. So where blockchain comes into place is that for example, you have different vehicles or different transport vehicles taking some kind of inventory or supplies to a different region, a country or somewhere else. They all are equipped with IoT devices that send real-time data to your system, and then that data is stored onto the blockchain part, and that copy of blockchain is shared among the stakeholders or the you could say different shareholders of that supply chain company, so they can track their data in real time. They can see the location of the data, the amount of data, or if it has been tampered or not. So this is where blockchain comes into place. So they create different there is a term called SSE, server sent events. What happens is that when you query the data on IoT devices, it keeps sending data after every second or after every 5 seconds. This way, whenever something is basically removed from that hardware, something like some materials or some inventory, it automatically gets updated, and it can then show you that the previous this item, that particular item was previously found here, and it's not no longer in inventory or something like that. Yes. Also helps you with stock shortages, so you can prepare yourself in advance if there is any stock short or something like that. Yes.
So basically, it is for managing the supply chain.
Yeah.
Not for the security of.
I mean, it serves some kind of security, but then again, everything on the internet is prone to attacked or getting hacked. So yeah, it just adds another level of security to that. Smart contracts, as the name suggests, they are contracts between, like, me and you had a transaction about a car or something. Then we can, instead of writing a contract manually, we can do it in the form of a smart contract, where we'll write different functions that when the certain amount gets transferred to your account, the asset ownership will automatically be transferred to my name. This is how smart contracts work. When we work with digital assets like NFTs, I was explaining. So this is how the transaction actually takes place. I buy something from you, and I will write a smart contract with different information about you and our bank details, and once the money is transferred to you, or the cryptocurrency is transferred to you, the asset ownership will automatically be transferred to me or on my name.
Real-time scenario, how you work on blockchain, different blockchain. Can you explain the real-time scenario of the cryptocurrency?
Real time, I can show you the.
Maybe you will
I will show you. It's actually lengthy. This is an example of a smart contract. So as you can see, here the assets are being declared. Here is the document structure or car structure or whatever you're using. Then we have different kinds of functions that actually just work with the transaction, and once the transaction is processed, they transfer the ownership to the other user, or different stuff like that. So this is basically a true example of smart contract. It's written in Golang, and this is how things take place in